So let's consider this question to explain the concept of radial and transverse components. The question says, the robot arm in figure 3 is elevating and extending simultaneously. At a given instant, theta is equal to 30 degrees, theta dot equals 10 degrees per second equals constant, L equals 0.5 meters, I dot equals 0.2 meters per second, I dot dot equals minus 0.3 meter per second squared. Compute the magnitude of the velocity v and acceleration a at the gripped point P. In addition, express v and a in terms of unit vectors I and j. So let's start by picking out, okay, this is a diagram as can be seen. So you have the robot arm and you're given the angle theta. Of course, the total radius arm of the robot arm is simply from here to this point, and from here to here was given as 0.75, and from here to here was simply given as L. So let's pick out the value given to us in the question, or let's pick out our parameters. Now, in the question, you were given theta. They said at an instant, theta is equal to 30 degrees. So the angle theta was given as 30 degrees. You're also given theta dot equals 10 degrees per second. So you have theta dot, which is equal to 10 degrees per second. Now, we need to convert this theta dot in radians per second because this is actually the angular speed. So theta dot needs to be converted in radians per second. How do you do this? Since it's in 10 degrees per second, it becomes 10 times pi all over 180. This converts it to radians per second. So this simply implies that theta dot is equal to, let's obtain 10 pi, not forgetting pi is 3.142. So this is actually 10 times 3.142 divided by 180. So this simply implies that our angular speed theta dot is equal to. So I will punch everything all at once. So theta dot gives us approximately 0.1746 in radians per second. So these are theta dots. We were also given L to be 0.5. So you were given L equals 0.5 meters. You are given I dot to be 0.2 meters per second. You are given I dot to be 0.2 meters per second. So this simply means this is a velocity component in meters per second. You were also given I dot dot to be minus 0.3 meters per second. So you were given I dot dot to be equal to minus 0.3 meters per second squared. So from the unit, this tells you that this is an acceleration component in meters per second squared. Now you're asked to find the magnitude of velocity and acceleration. That's the first part of the question. But then let's take a look at the diagram once more. Observe that the radius arm of this robot arm, radius is simply 0.7 plus the length L. That gives us the total radius arm. So you need to find your radius arrow. Arrow equals 0.75 plus L. But in the question, we are given L to be 0.5. This simply implies that arrow is equal to 0.75 plus 0.5. And therefore, the radius arm arrow is simply equal to 0.75 plus 0.5. That gives us 1.25 in meters. Now, for the motion of this object, we need to find the radial component of the velocity and the transverse component of the velocity. Then compute the magnitude. Okay, so first we'll find radial velocity. And radial velocity v arrow is simply given as arrow dot, which is in meters per second. But in the question, you are given I dot to be 0.2 meters per second. So I dot is simply what? Arrow dot. So which means radial velocity is simply 0.2 meters per second, already given to us in the question. Now the next thing to do is to find the transverse velocity. So you find transverse velocity, which is v theta, and v theta is simply given as arrow theta dot, arrow theta dot. Okay, So this is equal to arrow is 1.25. Now, what is theta dot? We've already found theta dot over here to be 0.1746. So multiply by 0.1746. So this simply implies that the transverse component of velocity is equal to, let's obtain 1.25 times 0.1746. That gives us 0.2183 approximately. 0.2183 in meters per second. So this is our transverse component. Therefore, our velocity magnitude is equal to the square root of the square of the radial component of velocity plus the square of the transverse component of velocity. So this is equal to the square root of radial velocity gave us 0.2 meters per second. So you have 0.2 all squared plus transverse component gave us 0.2183. So you have plus 0.2183 all squared. So this implies that the magnitude of the velocity is equal to. So I'm going to be pointing everything all at once. So it means V is 0.296 meters per second. So this is our velocity magnitude. The next part of that question says find the magnitude of the acceleration as well. So we need to find acceleration. Just like we did in the first case, we'll also find the radial acceleration and the transverse acceleration. Okay, so let's do it and see. Now we find radial acceleration. And the radial acceleration AR is given as r dot dot minus r theta dot squared. Okay, so and not forgetting in the options you are given I dot dot be equal to negative 0.3. So I dot dot simply stands for r dot dot. Okay, so I dot dot radial acceleration is equal to I dot dot simply stands for negative 0.3 minus 2 times r, and r is 1.25 times theta dot squared. Once more, theta dot will obtain the value to be equal to 0.1746. 0.1746 all squared. So this implies AR is equal to minus 0.3 minus, let's obtain this multiple and see 0. So you have 2 times 1.25 times 0.1746 all squared. That gives us 0.0762 approximately. Okay, so if you compute this, this implies that the radial component of acceleration, so we do minus 0.3 minus 0.0762. That gives us approximately minus 0.3762 in meters per second squared. So this is our radial acceleration. Keeping this aside, now we find the transverse acceleration. Now, transverse acceleration A theta is simply given as arrow theta dot dot plus 2 arrow dot theta dot. This is our transverse acceleration. Now, recall you are given theta to be equal to 30 degrees. You are also given theta dot. Theta dot will obtain the value as 0.1746 in radians per second. So this means that we cannot find the value of theta dot dot since none of these values are expressed with respect to time t. So differentiating this either of these with respect to time simply gives us 0. Okay, so differentiating theta dot with respect to time to obtain theta dot dot becomes 0 because there's no variable t attached to it. So the double derivative of that function equals 0. Okay, keeping this in mind, now we can find our radial, now we can find our transverse acceleration. A theta is equal to, remember, arrow, and arrow was given as 1.25 multiply theta dot dot is 0 plus 2 times arrow dot we know is I dot, which is given as 0.2 times theta dot, and theta dot was given simply as 0.1746. So 1.25 times 0 is off, that 0. We simply compute the multiple of everything here. This implies that the transverse component of acceleration is equal to, let's obtain that multiple, 2 times 0.2 times 0.1746. That gives us 0.0698 in meters per second squared. So this is the transverse component of the velocity. Having found this now, we can now compute the magnitude of velocity. Now, so this is the transverse component of the acceleration. Having found both radial and transverse component of acceleration, we can now compute the magnitude of the acceleration. Therefore, acceleration A is equal to the square root of A arrow squared plus A theta squared. This is equal to the square root of the radial component of acceleration. A arrow gave us minus 0.3762. So you have minus 0.3762 all squared plus A theta gave us 0.0698 all squared. So I'm going to be pointing everything all at once to obtain a value. 0.0698. So upon squaring and taking square root, we have acceleration we have the acceleration so we have the acceleration A to be equal to 0.3826 in meters per second square. So this is the magnitude of the value of the acceleration. Okay, so this is the first part of the question answered. The second part of the question says we should express the velocity and acceleration in terms of unit vectors I and j. Okay, so to express the velocity and the acceleration in vectors form, let us consider this diagram. Let's consider a right angle triangle. Let's consider simply a graph. Remember, this is our x-axis, this is our y-axis, and of course the x-axis is always the I direction, the y-axis is always the j direction. Let's say we consider the radius arm of that robot from the origin. Let this be the radius arm arrow. Now, in the x direction, the x component is given as xi in vectors form, whereas in the y direction, y component is given as yj in vectors form. So you can simply even form a height from here, which also still represents the y direction. So this is y j. Now let this be the angle theta between the radius arm and the horizontal. Now the radius arm in vector form arrow, the radius arm arrow is given simply as xi plus yj, the sum of the positions in the I and j direction. So the radius arm is simply given as xi plus yj. Now to find velocity, it means we have to differentiate the radius arm once. So that is arrow dot, which is equal to x dot I plus y dot j, which means differentiate x and y if you're looking for arrow dot. Now to find acceleration, it means you have to differentiate the radius arm twice. That gives us arrow dot dot, this is equal to x dot dot in the I direction plus y dot dot in the j direction. So this is our velocity and this is our acceleration. But then what is x and what is y? Now take a look at the diagram. You can find the value of either x and y using your trigonometry. So recall, sine theta is opposite and opposite is the y direction. So opposite is y all over hypotenuse is the radius arm arrow. So this simply implies that my y is actually what? Arrow sine theta, keeping this equation aside. Keeping this equation aside. Similarly, I can find the value of x as well by relating cos theta is equal to adjacent. Adjacent is x all over hypotenuse. So I have x all over hypotenuse is arrow. So this simply implies that x can be found by what? Arrow cos theta, keeping this aside. Now, if you know these values for x and y, not forgetting to find velocity, we have to what? Find x dot and y dot. Also, to find acceleration, we have to find x dot dot and y dot dot. So let's differentiate x and y once and twice. Okay. So from x equals arrow cos theta, let's find x dot. X dot is equal to differentiating x with respect to time. Okay. Remember, this is now product of two functions, arrow multiplying cos theta. And by product rule, keep the first one constant, differentiate the second, plus now you keep the second constant, differentiate the first. Let's say, for instance, you have y equals u times v. From product rule, we say y prime, which is the y the x, is equal to hold u constant, differentiate v with respect to x, plus now you hold v constant, differentiate u with respect to x. This is simply the product rule. So that's how we differentiate this function. Okay, now I will hold r constant, then I will differentiate cos theta with respect to t. But to differentiate a trig function, first of all, differentiate the angle. Then after differentiating the angle, use that derivative to multiply the derivative of the trig function itself. The angle here is theta. If I differentiate theta with respect to t, I will simply have theta dot. Use this theta dot to multiply the derivative of the trig function. If I differentiate cos, I will simply have minus sine theta. So that's the first rule obeyed. Hold arrow, differentiate cos theta, plus. Now you hold cos theta, differentiate arrow. If I differentiate arrow, I will simply have arrow dot, and you have this. So this implies that x dot is equal to, you simply have, this is arrow. Remember, there's a negative sign here, so you have minus arrow theta dot sine theta plus arrow dot cos theta. So this is our x dot. Now, knowing the values of arrow, theta dot and theta, you can go ahead to find the value of x dot. But before doing that, let's find the double derivative, x dot dot. So this is going to be equal to, so to find x dot dot, which means the double derivative of this given function, first of all, you understand that the first part, this is a triple functions, one, two, three functions multiplying one another. So you have arrow multiplying theta dot multiplying sine theta. So we are simply going to employ the triple product rule. So it's just similar to the double product rule when you have double functions multiplying one another. In this case now, what we'll do is you hold two function constants, differentiate the other, plus hold the other two constants, differentiate again, then hold the remaining two constants, differentiate. So you keep on holding two constants until you're done differentiating each of them. That's how to employ the triple product rule. So let's do this and see. Now, keeping in mind negative is a constant sign, so we can just simply keep this negative sign out and open a very big bracket. Now, I want to keep arrow and theta dot as a constant, so you hold arrow, hold theta dot as a constant. Let's differentiate sine theta. But now remember, to differentiate sine theta, this is a trig function. First thing to do is differentiate the angle theta, use the result to multiply the derivative of the trig function itself. Okay, so if we differentiate the angle theta, we are simply going to have theta dot. Use this result to multiply the derivative of sine. If I differentiate sine, I will simply have cos theta. Close your bracket. So that's the first. Hold arrow theta dot constant, differentiate sine theta plus. Now you hold theta dot and sine theta, then differentiate arrow. So if you differentiate arrow, you simply have arrow dot. Then you're holding theta dot and sine theta as a constant plus. Now you hold arrow and sine theta as a constant, then differentiate theta dot. If Okay, so you keep arrow as a constant. If you differentiate theta dot, you simply have theta dot dot. It becomes a double derivative. Then also you're holding sine theta as a constant. So you hold arrow as a constant, you hold sine theta as a constant, then you differentiate theta dot. So that's it on this particular derivative. Now plus, this is now derivative of two functions, product rule once more. So you're keeping arrow dot, differentiating cos theta, plus now you keep cos theta and differentiate arrow dot. So we can do that underneath here. So you hold arrow dot, differentiate cos theta, but remember, to differentiate cos theta, you have to first of all differentiate the angle theta. So differentiating the angle, you have theta dot. Okay, use this derivative to multiply the derivative of the trig function cos. If I differentiate cos, I will simply have minus sine theta. Okay, so keep r dot constant, differentiate cos theta, which is what we've done, plus now you keep cos theta as a constant and you differentiate r dot. If you differentiate r dot, you simply have r dot dot, then you hold cos theta as a constant. So that becomes the derivative of that function. So let's rearrange everything now and see. Okay, so x dot dot is now equal to, we can simply evaluate with this negative sign, allow the negative sign now to multiply everything in the bracket. So minus times this gives us, remember, I have theta dot times cos theta here. So theta dot times theta dot gives us theta dot squared. So this becomes minus arrow theta dot squared times cos theta. You hold this again, minus times this plus here becomes minus. I have r dot theta dot sine theta. Okay, again minus times this plus becomes minus. I have arrow, I have theta dot dot, I have sine theta. Okay, now minus here, multiply this plus becomes minus. I have r dot theta dot sine theta, so this is r dot theta dot sine theta plus, I have here r dot dot cos theta, so this is r dot dot cos theta. So we have this. Okay, so let's see if anything can add or subtract in this equation. So if you look through this equation, you observe that we have minus r dot theta dot sine theta, and we have here minus r dot theta dot sine theta. So which means these two can add negatively. Okay, so we have x dot dot to be equal to, this is minus r theta dot squared cos theta minus r dot theta dot sine theta minus r dot theta dot sine theta. This gives us minus 2 r dot theta dot sine theta, okay, minus r theta dot dot sine theta plus r dot dot cos theta, and we have this. So let's pick out the values. So now we know x dot dot and we know what x dot means. We can plug in the values given to us in the question and find a real value for x dot dot and x dot. Okay. So not forgetting, in the question, we were given r to be equal to 1.25 meters. We solved this out, okay, and we were given theta dot to be equal to 0.1746 radians per second. We are also given angle theta to be 30 degrees, and I said since we are given theta dot to be this means theta dot dot differentiating this twice because this is a constant now, so theta dot dot to be equal to 0, and also we are given r dot to be equal to 0.2 meter per second. So let's plug in these values into, let's start with x dot. So we have x dot to be equal to, so remember from here we have minus arrow theta dot sine theta. So this is minus arrow is 1.25. So you have 1.25 multiply theta dot, and theta dot is 0.1746. So we have 0.1746 multiply sine theta. So multiply sine theta itself is 30 degrees. So multiply sine 30. Okay, plus from here this is arrow dot cos theta, and arrow dot gave us 0.2, so you have plus 0.2 multiplied by cos theta, that becomes cos theta is 30, so you have cos 30. So let's evaluate and obtain a result for x dot. So upon evaluation, minus 1.25 by 0.1746 multiplied sine 30 give us minus 0.1091, plus you have a 0.2 multiplies cos 30, that gives us 0.1732. So minus 0.1091 plus 0.1732 simply gave us this value 0.0641 to be the value of x dot. Now we plug these same values into x dot dot as can be seen over here. So x dot dot, let's obtain the value of x dot dot. So in x dot dot we have minus arrow theta dot squared cos theta. Once again we have minus arrow there is 1.25, so minus 1.25 multiply theta dot squared, and theta dot is 0.1746, so multiplies 0.1746 all squared times cos theta, so multiply by cos theta there is 30 degrees, okay, so multiplies cos 30, all right, minus you have 2 arrow dot theta dot sine theta, so this is 2 times arrow dot gave us 0.2, so 2 times 0.2 multiplies theta dot, and theta dot gave us 0.1746, okay, multiply sine theta, so times sine theta is 30, so multiply by sine 30, okay, so you have minus arrow theta dot dot sine theta, so that gives you minus arrow is 1.25 times theta dot dot is 0, so multiply 0 multiply sine 30, and finally plus arrow dot dot sine theta. So you have plus arrow dot dot was given to us in the question. Okay, so in the question, arrow dot dot, we explained this earlier, was given as negative 0.3 meters per second. Okay, so in place of arrow dot dot cos theta, arrow dot dot is negative 0.3 multiplied by cos theta, and theta is 30 degrees. So we simply have negative 0.3 multiplies cos 30 degrees. Okay. Alright, so upon evaluation, we have x dot dot to be equal to negative 0.3277 meters per second squared. Not forgetting, over here we have 1.25 multiplies 0 multiplies sine 30, so which means everything here is completely 0. So if you evaluate everything together, you can do well to point along with me and confirm this result, but this is what I obtained for x dot dot. Alright, so having found x dot dot, next is to find y dot and y dot dot. So let's recall the value of y. Recall, we had y to be equal to, so from the diagram earlier, we had y to be equal to arrow sine theta. So let's fall back to it. So we have y to be equal to arrow sine theta. So now we have to find y prime, y dot, sorry, and also we find y dot dot. Okay, so let's find y dot. Y dot is equal to, now this is a product of two functions. From product through, you hold arrow constant, differentiate sine theta. But to differentiate sine theta, first of all, you differentiate the angle theta. If I differentiate angle theta, I'm simply going to have theta dot. Now use this result to multiply the derivative of sine. If I differentiate sine, I will simply have cos theta, okay, plus. Now you keep sine theta as a constant, then differentiate arrow. So you hold sine theta as a constant, differentiate arrow. That will give me arrow dot. All right. So this simply means that y dot is equal to, this gives me arrow theta dot cos theta plus this is arrow dot sine theta. So you can go ahead by putting in the values of arrow dot, theta dot, arrow and theta into this equation to obtain an actual value for y dot. But let's further differentiate to obtain y dot dot. So y dot dot is now equal to, just like we did before, this is now product of three functions. So we are going to be holding two constant and differentiating until we are done differentiating each of the terms. So let's hold arrow theta dot as a constant, then let's differentiate cos theta. So to differentiate cos theta, remember, first of all, differentiate the angle. That gives you theta dot. Use that result to multiply derivative of cos. This gives you minus sine theta, okay, plus. So you're done differentiating cos theta. Now you can hold theta dot and cos theta, then differentiate arrow. So you hold theta dot cos theta and you differentiate arrow. I will simply have arrow dot. Okay, so you're done differentiating arrow now. Next is to differentiate theta dot. So you simply hold arrow and cos theta. So I have plus arrow cos theta. Now you differentiate theta dot. This simply gives you theta dot dot, and you have this. Okay, now plus. Now this is a product of two functions, so you can simply hold arrow dot as a constant, then you differentiate sine theta. Once again, you differentiate the angle first. That gives you theta dot. Use that result to multiply the derivative of sine, which will give me cos theta, plus. Now you hold sine theta as a constant, and then you differentiate arrow dot. If you differentiate arrow dot, you simply have arrow dot dot, which is double derivative of arrow. Okay, so you have this. So let's rearrange everything now and obtain a common term. So if you do that, you're going to have that y dot dot is equal to, there's a negative sign here, so you pull it out, minus arrow. I have theta dot multiplies theta dot. That gives me theta dot squared sine theta. Okay. Here I have, okay, this is plus arrow dot theta dot times cos theta. Okay, over here I have arrow theta dot dot cos theta, so plus arrow theta dot dot cos theta. Over here I have plus, this is arrow dot theta dot cos theta plus arrow dot theta dot cos theta, plus I have arrow dot dot sine theta. So you can put that down here, plus arrow dot dot sine theta. So let's look through this equation and see if anything can add or subtract. So you observe that we have plus arrow dot theta dot cos theta, and we also have plus arrow dot theta dot cos theta over here. So which means these two terms can add. So y dot dot is now equal to minus arrow theta dot squared sine theta. Okay, so plus arrow theta dot cos theta plus arrow theta dot cos theta gives us 2 arrow dot theta dot cos theta. Okay, sorry, so it's simply arrow dot theta dot cos theta plus arrow dot theta dot cos theta. Pardon me for that. Okay, All right, so we have here plus, this is arrow theta dot cos theta, plus finally you have arrow dot sine theta. So we go ahead now and plug in the values of arrow, okay, as stated earlier, into y dot and into y dot. Okay. All right, so now let's plug in their values, not forgetting. Now y dot is equal to, we said, arrow theta dot cos theta, and arrow is equal to 1.25, so that gives us 1.25 multiplies theta dot is 0.1746, so multiply 0.1746 multiplies cos theta, and theta is 30 degrees, plus arrow dot, and arrow dot is 0.2, so you have 0.2 multiply sine theta, that's simply sine 30. So this simply implies that y dot is equal to, so I'm going to punch everything at once. Do well to punch along to confirm the result. So upon evaluation, we had our y dot to be equal to 0.2890 meters per second. So let's plug in these values into y dot and obtain the result for it. Okay. Okay, so not forgetting, this is our y dot. So knowing this as our y dot, let's plug in these whole values into it. So y dot is equal to, we said, negative arrow, and arrow is 1.25, so minus 1.25 multiplies theta dot squared. Theta dot is 0.1746 all squared, multiplied by sine theta, which is sine 30, plus you have 2 arrow dot theta dot, so this is 2 times arrow dot is 0.2, so 2 times 0.2 multiply theta dot, which is 0.1746, multiply by cos 30, so times cos 30. Okay, we have plus arrow dot sine theta, so we have plus arrow theta dot sine theta, so plus arrow once more is 1.25, theta dot of course is 0. Okay, theta dot is 0, so multiply by 0, multiply by sine theta, which is sine 30, and finally plus arrow dot sine theta, and arrow dot is negative 0.3, so you have minus 0.3 multiply sine 30. Okay, so we are going to evaluate everything all at once, so do well to point along with me to avoid any calculation errors. Okay, so upon evaluation, we have y dot to be equal to negative 0.1086 meters per second squared. Mind you, over here we had 1.25 multiply 0 times sine 30, so which means everything here becomes 0. And of course, over here we have negative 0.3 multiply sine 30, that gives us negative 0.15. So if you add up everything, you're going to have y dot to be equal to negative 0.1086 meter per second squared. Okay, so the question is asking us to find velocity in vector form I and j, and acceleration also in vector forms I and j. So I've already done everything. I'm just going to explain this out here. So in vector form, velocity is simply equal to r dot, which is simply x dot in the I direction plus y dot in the j direction, and we obtain our x dot to be equal to 0.0641 in the I direction, plus we obtain our y dot to be 0.2890 in the j direction. So this is simply our velocity in the vector form, whereas our acceleration simply means r dot, and r dot is equal to, we have x dot in the I direction plus y dot in the j direction, and these are the values for x dot and y dot. So simply append your vectors I and j to it, and that becomes the velocity and acceleration components in the I and j direction. That's it for that video, guys. I hope you find this video interesting. Please, if you do, I would like to get your thoughts in the comment section, and if you're new to the channel, Do well to also subscribe to keep getting updates when such videos drop. I will see you in the next video. Thanks and cheers.